WC, AltConf. My name is Reza. I'm a software engineer with Square, and today we're going to learn how to train our own model for CoreML. Now, given that this talk is going to be 40 minutes long, I may speed through some sections of the training process, or I may cut some aspect of it out. But I do want you guys to know that this talk is based on an article that I wrote earlier. So if you find this interesting and if this is something you want to do on your own, you can find that article on my website, Reza.code, where I go through the whole process in detail with screenshots and sample code and all that good stuff. You can also find me on Twitter. My handle is @KingReza. Feel free to reach out if you have any questions, or if there's any way I can help. Now, before we get started, I just want to go over 2 quick points. The first one is that there are many ways to do the same thing. This is true in life, and this is true in training a model. There are many different technologies and services available for you to basically grab a model, train it, and deploy it into an iOS app. And of course, yesterday, a new way was introduced, CreateML. And I'm going to touch on this a little bit. This is all new for me. But I found some interesting stuff in the talk that kind of aligns with the process that we're going to go through. And it's going to be a little bit like a theory, but we'll get to it. We'll get to more details on that in a bit. So that's the first thing. There are many ways to do it, and I'm going to introduce one of many ways in which you can get a model, train it, and deploy it into an iOS app. The second thing that's worth noting is that you don't need to be an expert. Machine learning has come a long way in the past few years. I myself don't have a PhD in machine learning. I've never worked as a data scientist for any company. I just found it interesting, and I dug deep and went through the documentation and managed to put something together fairly quickly. So machine learning has become extremely accessible, cheap, and powerful. So if you are interested, you'll be surprised by how far you can go with a little bit of grit and willingness to learn. So this is what we're going to do in the next 40 minutes. I'm going to train a cafe model of type AlexNet using digits on an EC2 instance of type G22X large. And then we're going to convert it into a CoreML model using CoreML Tools and integrate it into an iOS app using Xcode and Swift. Now, this is a lot of stuff, I know, and I'm sure there's some of you who completely understand this. But for the rest of us, perhaps the iOS and the Xcode and the Swift might seem more familiar. My hope is that by the end of this talk, you would have an understanding of what all of this is and how they come together and play together into having a model, train it, and integrate it into an iOS app. So this is a boring definition of what we're going to do, and what we're going to end up with is this. So we're going to basically build an image classifier, which is capable of detecting from 101 different dishes as the camera points at the dish. Of course, this idea was first introduced in HBO Silicon Valley Seafood, but the thing is we're going to take it beyond hot dog, not hot dog, and actually train a model to be capable of detecting these dishes. I'm going to wait a bit for this to go through because I'm really proud of filming this. It was a lot of fun. When I walked out of Safeway with all these different foods and stuff, it was the person who was selling it to me. It's like, this guy's crazy. Great. So when it comes to training a model, there are a few things we need. And the first thing we're going to need is a computer. And hopefully we can get a fast and powerful computer. Now, what does it mean to have a fast and powerful computer? The type of calculations and algorithms that go into training a model at neural networks are very similar to the type of problems that we've been solving for a long time. And that's within the scope of computer graphics. We've spent a lot of time optimizing for these type of problems, and anybody who here plays video games can attest that within the past 30, 40 years, computer graphics have come a long way. And now, it just so happened, all that investment that we made in computer graphics is translated into something completely different in machine learning. We have introduced a hardware solution for computer graphics within a GPU. And if you have a GPU, if you have a computer that has a GPU, you can use that power within machine learning. And of course, for this specific example, you can run the training model on your own laptop and it'll work. But once you get into the habit of playing around with different models, running multiple sessions, trying out different ideas, you'll start to see that it's going to take a long time to complete what you want to achieve. And time becomes a variable, a resource that feels scarce. So there are two things you can do. One of the things you can do is go out and buy a computer that has multiple GPUs and run concurrent trainings on that computer. Of course, that's going to cost you thousands of dollars. It's going to be a lot of money. And the other thing you can do is you can employ cloud computing, which kind of makes it easy for you to get into training. And depending on the problems you want to solve, we can instantiate an instance of some computer in the cloud that has the amount of GPU and the amount of power you need. And once you're done, you can shut it down. And for this example, I want to go through the process of doing that. When I discuss this type of stuff with iOS engineers, they tend to agree that perhaps back-end stuff, instantiating instances is something they may not have experience with. So I'm just going to quickly go over through that process with you guys so we get that experience. So what I'm going to do is that I'm going to launch an EC2 instance. EC2 is Elastic Cloud Computing, which is Amazon's way of saying a computational unit in the cloud. So to get an EC2 instance running, you simply log into AWS, you sign up, and then you go into launch an instance. Here you're going to see a bunch of operating system images. And Amazon has recently added some deep learning specific ones too, which I haven't had a chance to play around with, but again, go back and try it out. But for this specific talk, we're going to use a community AMI, which is called Big Vision Digits. Now, this specific AMI has an operating system and has a bunch of software that I'm going to use for the training already installed. So I'm going to select this one. And in here, I'm going to select the instance type. And down here, I'm going to select the G22X large, which has 1 GPU. Again, depending on the problems you want to solve, you can pick a bigger one or a smaller one, whatever fits your needs. Then we're going to configure. Nothing here really needs to change. You're going to add storage. I like to go with something a little bit bigger than 50 gigs, so I'm going to go 75. You go next. Nothing to worry about here. Configuring security. We open port 22 for SSHing into it. We're going to have a new one and open up port 80. And I suggest keeping this to your own IP. And then we're going to go review and launch. So once you have this up and running, you can click launch, and a new computer will appear in the cloud where you can have access to it. Now, this is going to take some time. I've already done that. And when you load it up and you go to that public IP that you get, you're going to get something like this. And this is called Digits. Digits is a web application that's developed by NVIDIA. It makes the process for training and managing the data that you're going to use for your training much easier. And we're going to go through it, and you're going to see where the value for this actually comes into play. So what is Digits? Definition. And there's a website. You can check it out for more documentation on what is Digits and how we can use it. So now we have our computer up and running. What is the second thing we're going to need to train the model? We're going to need data. And this is usually the most tedious and difficult part of training a model. It's going out and finding the data that's diverse, complete, and useful for training that model. Lucky for me, I was able to find this data set by just Googling around, and it's called Food 101 data set, which is actually part of a paper that's not related to neural networks, but the data set itself provided enough sample to get a fairly good trained model at the end. This data set has 100,000 images. Each one it's categorized into 101 different categories, so it's 1,000 image per dish. So it's an okay data set, and we can get some good accuracy with it. It's 5 gigabytes long, 5 gigabytes large, and we need to download this into the instance that we just launched. Of course, that process is going to take a long time. I'm not going to get into how to do that, but I've already done this on this instance, so the images and the data is available. Okay, great. Oops. So now that we have the data available, we're going to create a data set. Now this data set is basically going to take the images and the files and folders that we have created on this computer to put the images in, and it's going to create a local database that the training model is going to use for its training. This makes accessing the resources much simpler and faster. So to create a data set, we click on where our images are. We select it. We change this to crop because I ended up getting better accuracy when I changed that. Again, play around with these numbers, see what works best for you. We're going to have an LMDB database, which is a light memory database, and we're going to name this food AltConf, and we're going to click create. So now the application, Digits, is going to go through all the folders, grab all the images, and create this local database that's going to be used for our training. Of course, this is going to take 48 minutes. We don't have 48 minutes, so I've already done that. This is basically what you're going to end up with once the creation of the data set is complete. One of the other great things about Digits is that once you create your data set, you can go through and quickly, verify that everything seems correct and everything seems to be displaying correctly. Great. So we have our data ready. So what's the third thing we're going to need is a model. So a model is basically what we're going to train. It's a neural network that we're going to train against the data. And to do that, we are going to go to the right-hand side. I'm going to abort this because we don't need it. We're going to go to, I'm going to click on classifications. And in here, we're going to select our data set. And underneath Cafe, we're going to select AlexNet. So right now, we have two new things that I'm introducing, Cafe and AlexNet. So let's go over what those things are. Cafe is a deep learning framework that has expression speed and modularity in mind. It's basically a way to define how a neural network would function without actually worrying too much about the code. You can define the different layers in a text format, and then it's super fast, and because it's open source and allows for extendability, you can plug things in and out. Oops. And then AlexNet is an actual model that won the ImageNet competition back in 2012. It was trained against millions of images and can detect from 1,000 different objects, and it ended up winning by quite a lot. I don't really remember the numbers, but if you just Google AlexNet, it will come up. I have a link to the paper as well if you're interested in getting to the nitty-gritty details of what it is. So great, we have our model selected. This is a model that's going to be trained. We have our data set. That's it. We're going to select food AltConf, and we're going to create. So now what's going to happen is that Digits is going to take your data that you've had, and it's going to train the model against it. This is basically in a lot of ways like CreateML that was introduced yesterday. Apple is taking something like this and kind of build their own version of it. But this is going to take 4 or 5 hours, so again, we're not going to wait here for that to complete. If we click here, we can see the final result, and this yellow-orange bar is actually the accuracy rate that we got at the end. And now if we go to the end of it, we'll see that we got an accuracy of 47%. Now this is not very good. There's actually a trick we can use to make this better by quite a bit. And that's what we're going to do right now. So if we go back, I'm going to stop this task, and we go back in here, and we're going to image classification. We're going to select Food 101. We're going to select AlexNet. But this time, we're going to customize it. I already have an AlexNet that's been trained. This is the original model that was trained against millions of images and can detect from 1,000 different objects. And I'm going to take this model, and I'm going to fine-tune it with my data set. So basically, instead of training the model from the ground up with the Food 101 data set, I'm going to take one that's already been trained, and I'm going to fine-tune it. And I'm just going to quickly go off script here. Yesterday during the presentation, when they were going through CreateML, One of the big selling points of using CreateML was that you would end up with a model that's much smaller. And I think, I'm not sure, but I think the way Apple is doing that is they have a trained model on the device itself, and CreateML fine-tunes that trained model with the data set that you're providing, and then you end up deploying the difference, not so much the new trained model. To fine-tune an already trained model, there are two things you need to do. Let me just quickly show you another great thing about Caffe, is that you can actually see a visualized format of the neural network, and you see the different layers. What it takes to actually fine-tune an existing model that's been trained, two steps. Number one, we're going to take the last layer, which is responsible for assigning the labels, and change it. And the way to change it is to simply rename it. So I'm going to take every FC8 that I see in the model definition, and I'm going to replace it with FC8 food. And I believe there's 4 of these guys. Great, and I'd like to visualize it one more time just to make sure the last layer is actually changed to FC8 food. The next thing we're going to do is that we're actually going to reduce the base learning rate. This is a model that has already been trained. So what we want to happen is that when the new data is introduced, we want it to affect it in a smaller increments than a model that is being trained from the ground up. Again, this is a number that 1/10 of what it was previously ended up working better for me. This goes back to experimenting and seeing what works best for you guys. Great. So we are now going to fine-tune an existing model and fine-tune. Oh, great. And then the training begins. Again, this process will take some time. I have already completed it once, and we can see that the accuracy has gone up to 64%. Which is much better than 47. Again, if you get a larger data set that has more variety, you could probably end up with a better final result. Another great thing about digits, I know I'm like selling it really hard, but it's amazing. It's that once you have your model trained, you can actually test it right here on the web application. So if you, whoops, some of these URLs. Sushi one is good. All right, doesn't want to play nice today. There we go. So you can actually run the model against arbitrary images. In this case, I just linked it to a URL. It captured it, and it can predict with 99.31% accuracy that it's sushi. And then it provides more data on how each layer is getting activated. Again, this is great if you really want to get into the nitty-gritty details of how neural networks work and how your model is actually performing. Great, so our model is now trained, and we're ready to use it in our iOS app. So what we're going to do is we're basically going to go to FoodTrain and download the model. Now, I've already done that, and once you download the model, you're going to end up with these files. Now, right now we have a Caffe model, and we can't just take a Caffe model and put it into an iOS app. So there's another step we need to take, and that is to convert it into CoreML. Now, this may seem like a complicated process, and it probably is, but since the release of CoreML last year, Apple has also released CoreML Tools, which I think I have a slide on. Both think we need a CoreML model, and Apple has released CoreML Tools, which is an open source application that basically takes models from different frameworks and converts it into CoreML so you can easily integrate it into your iOS app. So that's what we're going to do. Now, to do that, we need to install CoreML. And you can do that by running pip install CoreML Tools. And that's it. You have CoreML now running on your computer. The next thing you need to do is create a file. In this case, I've called it run.py, and you're going to put the following code in it. This is Python. If you guys haven't played around with it, don't worry. It's going to be pretty straightforward. We're going to import CoreML Tools. We're going to create a CoreML model. It's going to be CoreML Tools. We're going to call the converters. We're going to select cafe, because that's the model we're going to convert. And we're going to call convert on that. The first parameter this method takes is a CoreML model, and the definition for that CoreML model is going to be the cafe model itself, the deploy.prototext, and the mean.binary proto. Now, these three files already come when you download the model, so you don't need to worry about it. The next thing we're going to have is we have to tell CoreML Tools what's going to be the image input name. In this case, it's data. If you ever want to know what that actually is, you can go in here and just look at your deploy prototext. The first line literally says what the input is going to be called. And after that, labels.text is just going to be your class labels, which is just a list of different things you're going to be categorizing on. So if we just look at that very quickly, these are basically different dishes that this model can categorize on. And then we have is BGR equals to true. This is the channel ordering, which for cafe models, from my experience, has always been true. Same with image scale. It defaults to 1, but for some reason for cafe models, it's always been 255. I know it seems like magic numbers, but that's just what has worked so far. Next, you're going to set author. You can add some metadata, and then finally, you'll save the model by calling CoreML model.save. And to run this, you simply go Python run.py, CoreML runs. It takes your cafe model, it converts it into a CoreML model. So if we go, you will see that you will have a new food ML model added to our folder. So now we're going to do something fun. Now that we have our model, we're going to integrate it into an iOS app. So the app that I have up and running, not running, but I have right now here, basically captures an image from the camera and takes that image and puts it on a UI image view on the screen. So you basically get a feed from the camera and you display it on the screen. Now what we are going to do is that we are going to add a new method in between called detect scene. And in that scene, we're going to try and classify the image that the camera has captured and see what dish or what food it's pointing at. So to do that, the first thing we need to do is import the model we just created. So we're going to go here, add file. We're going to go into our model, and we're going to select food ML model. And once you import it, when you click on it, you're going to get a screen like this where the metadata and some description about the model is presented. AlexNet is extremely large. If you ever want to do training, I suggest using SqueezeNet, which is a similar model but much smaller. And you can get 5-6 megabytes of size out of that one. And the most important thing here is that you want to make sure your input is an image and your output is going to be a dictionary of labels and probabilities. And make sure the target membership is also for the application that you're deploying. Great, so we have the model in. Next up, we're going to write the code that actually is going to do the detection. So we're going to have this function called detect scene. It's going to, can you guys see the code, or is it like super small? What was that, command plus plus? All right, great. So we're going to create a model, and the way to create that model is to call VNC Core ML model, and we're going to pass in this food. We're going to call model on this food class, and this specific object gets created when you bring in your model from CoreML. So this is just automatically generated code that you don't need to worry about. Once you have defined a model, we're going to create a request based off that model, and then we're going to pass it a closure where the request that is completed, and if any error that might have come up are going to be its parameters. We're going to go through the request and make sure it's an array of observations, and then we're going to take the first item that's going to be the one with the highest probability, and we're going to take the text for that label and show it on an actual label that's on the view controller. And once we have the request and once we have the model, we're going to create a handler by calling vn image request handler for that specific image, and we are going to perform that specific request that we have created using that handler. And that's it. So let me see if I can, this is usually the part that sometimes works really well and sometimes doesn't. We got plenty of time. Come on, you can do it. Nope. Don't want to do it? All right. If there's anything I learned from the talk before this one, it's to never give up. Grit will lead to success. I don't know why it's giving me a hard time with working earlier. Anyways, I have the app running on the phone, but I just can't get it to come up on the screenshot. So if anyone's interested, come by and I'll show you that it actually is detecting pizza. Oh, that's making me hungry. I'm going to try this one more time because it's really cool if I can get this working. Nope. You think closing Xcode will help? Restart the computer? Oh, the phone? But the Xcode is, yeah. Anyways, I don't want to take too much time. Come see me after the talk and I can show you that it's actually detecting. So in conclusion, we trained a cafe model. It was an AlexNet model. We used digits on an EC2 instance that we instantiated here, and we converted it to a CoreML model using CoreML Tools and integrated it into an iOS app using Xcode and Swift. And that is how you can train your own model for CoreML. Of course, now we have CreateML, which probably makes this much simpler and easier. But again, if you find this interesting, there are many ways to do the same thing. Really play around and see what works best for you. Again, my name is Reza. You can follow along with more details on my website, and you can add me on Twitter @KingReza. And yeah, that's it. Thank you so much. Any questions?
Do you mind talking a little bit about the layers you were thinking about copying?
Yeah. That's the thing. I'm not an expert. Honestly, that's like the type of stuff that if you really get into core machine learning, you can get more understanding of how these layers work. I have some high-level understanding, but I don't want to say something that may not be completely true. Which goes, again, like, with the point that I'm making. You don't need to be an expert. You don't need to know exactly how everything works to actually build something and get it up and running. But yeah, good question. Yeah. It ended up being 220 megabytes, which is extremely large. I recommend using a different model, like SqueezeNet, which is about 7 megabytes, much smaller, and you can get similar performance, same accuracy to AlexNet. I just use AlexNet because it comes by default on Cafe. Anything else?
Do you know about how much the EC2 costs per run of that?
You want to shut it off when you're done. So I'm not sure about the rates, but if you run it for like 5 hours, I think it ends up being like $10, $12. Again, don't quote me. These stuff change over time, which goes back to try out like different providers as well. This is just something because I already have an account with Amazon Web Services that I use. But they are expensive. You don't want to leave that running. You're going to get a big bill. Anything else, guys? Yes. It all depends on what's your definition of good enough. Like, what are you trying to do? Yes. Once you play around with it and try out different angles and different ways of looking at things, you will see 64%.
What kind of performance were you getting back on that closure? Was it taking a couple seconds?
No, it was actually pretty fast. Actually, it's gotten much, like with the first time I wrote this, I wrote it and I ran it on an iPhone 6 Plus, and it was much slower, but with the iPhone 10, it's much faster, and it's kind of too fast because the labels keep changing much more quicker than before. Again, come see it. I'll show it to you. And yeah. So the performance is good. Like the fact that something like that can run in real time on your actual device is really impressive. Great. Awesome. Thanks so much, guys. Really appreciate it.